All right, let's do this. Today, we're building Discord. Well, kinda. We're going to design the absolute core, the engine that makes real-time chat possible for millions and millions of people talking all at once. This is the blueprint. Let's jump right in.
Okay, so here's the challenge. You need to build a real-time chat app. Messages have to show up instantly for literally millions of users. Sounds simple enough, right? Wrong. The fundamental way the web was built is actually working against us here.
You see, to make this happen, we have to take a core principle of modern web architecture, something we talked about back on day 10, and just shatter it. Remember how we said servers should always be stateless and forget you immediately? Yeah, to build real-time chat, we have to break that rule, big time.
And that gets us to the heart of the matter. The whole web runs on this protocol called HTTP. And for what we're trying to do, live chat, HTTP is just fundamentally broken. Let me show you why.
So here's the deal with HTTP. It's a request-response protocol. Think of it like this. Your phone, the client, asks the server a question. The server gives an answer, end of conversation. The server absolutely cannot start a conversation on its own. It can't just tap your phone and go, hey, you've got a new message. It has to wait to be asked. So, what's the first idea that probably pops into your head? Well, if the server can't talk first, we'll just make the client ask it. Constantly. Over and over and over again. This brute force approach has a name. It's called polling.
And this just shows you how ridiculous it is. Your phone makes a full connection to the server and asks, anything new for me? The server checks, says nope, and hangs up. Then, a second later, your phone calls right back and does the exact same thing. It is a never-ending cycle of asking and getting rejected.
Now, for maybe one or two people, this is clumsy, but it works. But remember our goal? We're building for millions. At Discord's scale, this simple idea isn't just inefficient. It's a complete catastrophe waiting to happen. Here's a reality check. Imagine you hired a mailman who is just absolutely exhausted, sweating, and sprinting back and forth to your mailbox, checking to see if there's a letter. He checks, sees it's empty, sprints back to the post office, and then immediately turns around and sprints back again. All day. That's polling. It's insane. Let's put some real numbers on this madness. Let's say we have 10 million users online at once. If every single one of their apps polls the server just once per second, that's 10 million requests hitting our system every single second. And here is the absolute kicker. 99.9% of the time, what's the answer to those 10 million requests? Nope. No new messages. You are burning an unbelievable amount of CPU, network, and database power just to say nothing's happening 10 million times a second. You will literally melt your servers. Okay, so polling is a total dead end. It will not work. We need something better. We need a way for the server to tell us when there's a new message. And thankfully, someone invented exactly that. It's called the WebSocket, and it changes the entire game. So what is a WebSocket? It's a totally different kind of connection. Instead of that constant asking, the client opens up a single permanent two-way tunnel to the server. It's like having an open phone line where either person can talk at any time, instead of sending a million texts asking, "Can I talk now?" I mean, just look at the difference. It's night and day. On one side, you've got HTTP polling, just this chaotic mess of temporary connections, all initiated by the client. And on the other, you have a WebSocket, one clean, permanent connection where the server can push data to you instantly, the very moment something happens. So how does this magic actually work? How do we create this special connection? Well, it all starts with this really clever trick. The client sends what looks, for all intents and purposes, like a totally normal HTTP request. This is the handshake. It's designed this way on purpose so it can sneak past firewalls that only expect normal web traffic. But here's the secret. Buried inside that request is a special instruction, an upgrade header. It's basically a secret password. The server sees this, understands the request, and if it agrees, the connection fundamentally transforms. It's not a request response anymore. It is literally evolved into a living, persistent WebSocket. Just imagine it like this. A single, glowing blue data packet flies from your phone and smacks into the server. And the second it hits, bam! A thick, persistent neon tube snaps into place, creating this permanent data highway between your phone and the server. And now, messages can just flow freely back and forth as these little orbs of data, instantly. So this new power is incredible. we've solved the real-time problem. But using it forces a massive, and I mean massive, change in how we have to build our servers, and it comes with some pretty serious trade-offs. And here it is. Plot twist. The golden rule for building huge, scalable websites is that servers must be stateless. They process a request and immediately forget who you are. WebSockets force us to throw that rule right out the window. This is the huge trade-off we have to make. A stateless server is easy to scale. Any server can handle any request. But a WebSocket connection is stateful. Your phone is now permanently tied to one specific server. That server has to hold your connection open and remember who you are. And you guessed it, if that one server crashes, your connection is gone. This stateful world creates a brand new puzzle for us to solve. Okay, so Alice is connected to chat server 1. Her friend Bob is connected to chat server 2. How on earth does a message from Alice get to Bob? Server 1 has no idea where Bob is. To solve this, as we learned on day 12, we need a central post office, a message queue. So let's follow a message from start to finish. Step 1, Alice types her message and hits send. It goes down her open WebSocket to chat server 1. Step 2, server 1 doesn't know what to do with it, so it just drops the message into a central message queue. Think of it like a massive highway for all messages. Step 3, server 2, which is holding Bob's connection, is constantly listening to this highway. It sees a message for Bob, grabs it, and finally sends it down Bob's open WebSocket. And just like that, it pops up on his screen. So there you have it. That is the blueprint. Stateful WebSocket servers managing all the connections, and a message queue acting as the grand central station routing everything. We've built a scalable, real-time chat system. But everything we've built is designed for tiny bits of text. What happens when we try to send video? We've actually done it. We broke the foundational rules of the web to create a system where millions of messages can fly around the world instantly. This combination of stateful connections with a central stateless router is the key pattern behind almost all modern real-time apps. But now for the final big question. This whole architecture works great for little text messages, but what happens when the message is a massive, live 4K video stream? Can a WebSocket even handle that? Can our servers handle that? Well, the answer is not really. Pushing that amount of data requires a whole new set of tools and protocols, and that's exactly what we're tackling tomorrow. On day 28, we are diving deep into the world of video streaming protocols like HLS. Make sure you hit subscribe so you don't miss it.